Yes, ladies and gentlemen, it is an honor to be here. I think it was very nice to see Chris Davis' slides about this bridge repair project. I did my PhD in hydrodemolition, but I would prefer to call it water jet technology because I don't think we demolish the bridge. We are making it, prepare it for repair. Demolishing, that is what criminals are doing, perhaps. Okay. So I will say something about maintenance for improved sustainability and Swedish conditions, preventive bridge maintenance, cleaning operations, laboratory tests, and then concluding remarks. But first of all, I will say something about Michael Sprenkel. I have had the pleasure to be in the same committees as him, 546 repair and 345 for construction of bridges. And I think we had a lot of fruitful discussions. Sometimes coming from Sweden, it's not just another country or another continent. Sometimes it's like another planet coming here to all you North Americans, and you have your procedures, you have your own units, and for me, PSI, and I struggle with them. But sometimes I have recognized that you are starting to use kilogram, but that is only for carbon dioxide, which carbon dioxide, kilogram carbon dioxide per cubic yard. That is a little bit strange. But Michael Sprenkel, he had a great experience, and we had sometimes nice discussions. He was always curious, interested, and a good listener. But I remember we had a debate on how to make a crack repair. He wanted to have it with the sloped edges, but I preferred the straight ones. I don't know if we ever solved it. So, do you know, for instance, that it is Portland Cement is celebrating 200 years this year. Aspin in UK invented it in 1824. But if I go 100 years back instead, I think it was the same here in US, that materials were expensive, but labor was inexpensive, and we made an optimization. So we tried to use as little cement as possible by using large aggregate particles, for instance, and the rebars were you didn't use the same amount as a support as in midspan, which we made later. But then if you go 60 to 10 years ago, the materials were relatively cheap and labor was expensive, and then there was a throwaway system. We made simplifications, one size fits all, and repair and maintenance were too expensive. It was better to demolish and rebuild. But today it is the opposite again. I think the material savings are necessary. Labor is still expensive, but we need to make an optimization due to the sustainability. And one possibility is to try to prolong the use of our structures instead of replacing them. So I'm coming from the Sweden in the north of Europe, and you can see I coming from the capital Stockholm, and you see that the temperature, this is during the year. So if we count the number of passes through or touching zero, it was 267 just in 1 year, and that makes the use of de-icing salt very intensive. In the north of Sweden, when it is 20 degrees below zero, then we are perhaps using it much less because it has no meaning to use it. But in Stockholm, I think sometimes like 65 occasions every winter. And that is, of course, a extremely aggressive environment for both reinforced concrete and steel structures. So the Swedish Transport Administration, they are giving recommendations for preventive bridge maintenance, And there are some issues you should do. Cleaning, water flushing once a year. You should secure a well-performing drainage. You should eliminate settlements. You should combat vegetation. You should repair the railings, and you should tighten minor cracks. That is the items. And here is a slide showing a poor cleaning. Water will resist here, and also salt, and you will have exposure during the entire year. Here is a broken drainage. You see that all the water will come to the bottom of this column. And here is a settlement. It is always the joint between the road and the bridge deck is of course complicated. And here you can see vegetation. It might look nice, but it also keeps all detrimental items of the bridge. And here is a railing deformation. And then you can ask yourself, how often are you cleaning your car? Hands up. My wife cleaned my car previous week. And how often are you brushing your teeth? I do it twice a day, not just once a year. So the regime for water cleaning, according to the Swedish Transport Administration, they have changed it several times. The first time it appeared in the code, that was 1969, and then they said that all surfaces of a structure are to be kept free of vegetation and contaminants. And then 10 years later, cleaning should be performed after the end of the de-icing period. In Stockholm, we are using de-icing salt at least in March and perhaps in beginning of April some years. It depends on if it is snowing. And then 1998, I think they were quite innovative because they said that surfaces should be 95% clean and of visible contaminants. Okay? But I think that was a little bit difficult to interpret. But how do you define clean? How do you measure cleanliness? When should the surface be clean? Always. Does not 5% remaining salt lead to reinforcement corrosion in the long-term perspective? So I have written a couple of papers on this. And I don't know if the Swedish Transport Administration listened to what I said, but in 2013 they made a new recommendation, and now this is as far from performance criteria as you can be. Cleaning should be performed with high pressure water, 160 to 200 bars from a 150 to 250 millimeter distance. And the recommended temperature of the water should be 60 to 90 degrees, and it should be performed in between May 15 and July 1st. Okay? Do you think that the contractors are following these requirements? Okay. So I tried several years to receive money to do some tests on these, and finally I get money from the Swedish Transport Administration and some other partners, and I hired a PhD student, Louise Andersson, and she wrote a thesis, Continuous Preventive Bridge Maintenance. And she started to make a follow-up of how this water flushing is performed in the Stockholm area. And then she made a field test on a highway bridge in Stockholm. It was open for traffic in 1971. It is maintained not by the Swedish Transport Administration, but by the city of Stockholm. But they are following the recommendation of the Swedish Transport Administration. There is a speed limit on the road, which is 50 kilometers per hour. It has a moderate traffic, and it is extensive use of de-icing salt. It was during the winter 2017 to 18, 62 times. And the test was started in January 11, 2018, and it consists of 2 boxes. Each box consists of the 30 test specimens. And in both boxes there are 2 concrete types and the test variable, that is washing or not washing. So when the contractor comes and make the annual washing, we protect 50% of the test specimens from be washed, so that they are still dirty. Okay, so we tried to estimate a concrete of the type that was used in the 1960s, and that time we used the water-cement ratio of 0.6. And I'm not very familiar with your classification of cement, but CM1, according to the Europe standard, that is a Portland cement containing at least 95% Portland cement, and then the other is gypsum. So that was used, and almost a similar one nowadays. But we have a little bit larger cement particles now than before. And in the recommendation today, you should have a water-cement ratio not higher than 0.4. And in the old times, we used natural gravel from the glacial period, which there are extensive resources, but they must not be used anymore. So today we are using crushed rock. We're making the concrete a little bit more complicated to place. And at old times, there was a recommendation of 3.5% of air. Today it is 5%. And then you can see that we measured after 2 years, there was a rather good difference between washed and unwashed, if you look at the chloride content. And measured as at the depth, you can see that the highest value is a little bit from the end of the structure. Also, in the case where it's not washed, you still have the rain, which is a natural way of washing. So that was the difference for the modern concrete was much smaller. And here you can see after 3 years, then there is hardly no difference, and that is, as you can see, just a minor improvement. So we were a little bit disappointed, of course, that we had anticipated a greater difference. But we think that it is too short time to look at this. So we started to make trials on accelerated tests. And if cleaning is beneficial, how to make it as efficient as possible? We need to look at a lot of variables, and then field test is not perhaps the quickest way to see which one is best. So we need to study the effect of water pressure, water flow, distance between nozzle and surface, water temperature, presence of detergent, concrete quality, etc. And field tests are also very expensive. And then we developed an accelerated test method. And in our case now we make 1 year in 1 week. So we have 1 day of winter, and then 2 days of spring, and 2 days of summer, and 2 days of fall. And you see that the temperature varies, and also the relative humidity. And we are when we are looking at the effect of cleaning, we are cleaning before the spring, and you see that we have a quite high concentration of salt. And here, after 8 cycles or years, you can see there is a rather large difference between washed and unwashed samples for water-cement ratio 0.6. And now, ladies and gentlemen, I come to my conclusions. The importance of maintenance and repair increases when considering sustainability. Preventive bridge maintenance contains several items, but cleaning with water flushing may be the most common one. The hypothesis is that cleaning reduces chloride ingress and thus postpone reinforcement corrosion. And field test shows some support for this hypothesis, but no final conclusion can be drawn. And I thought I had one another, because it says 1 out of 2. But this is 2 of 2. Yes, an accelerated test method has been developed. It can be used to test a large number of influencing factors. Preliminary test results indicate that washing has a greater effect on concrete with water cement ratio equal to 0.6 than if you are using a more durable one. So maybe washing could be limited to old concrete bridges where you use the rather high water cement ratio. But if a researcher doesn't say that we need more research, he will be fired. So more research is needed. The field test ought to be followed several years, and the number of unused test specimens is still large. Thank you, ladies and gentlemen, for your kind attention.